Welcome Algebra 2 students. Today we're going to be taking a look at solving quadratic equations by square rooting and factoring. This video is going to show you the first one of square rooting. Before we begin, fun little fact, 528 years ago today, Christopher Columbus made landfall in the New World in the Bahamas. So fun little fact for the day to get started. All right, before we solve, we must determine if there is just an x squared, and an x term, or x squared, x, and a constant. So I know that's a lot to take in. Let's just take a look real quick. And I already divided these into three categories. There's the equations we're going to be taking a look at, and it's important to kind of identify what they have in them because we're going to solve them a different way depending on what's involved. So the first thing we're going to take a look at is these first two equations over here. We just have an x squared term and then a constant. Okay, x squared term, constant. That's going to be important because we're going to solve these by square rooting. So let's take a look at how we do that. Okay, if we have x squared and a constant, there's no x term. There's no linear term here. No like 4x or 3x or minus 7x. So these are our steps. Go ahead and take a second, write these down. These are important. First, we're going to isolate the x squared. So we're going to get x squared equals everything else. Second of all, we're going to undo the square root sign by square rooting. Okay, square and square root are opposites. Don't forget this. I'll kind of get into it, but we're going to include plus or minus to get both a positive solution and a negative solution. All right, here we go. Let's take a look at this first one. We have negative x squared plus 4 equals 0. First, identify. Is there an x term? No, there's not. We just have a negative x squared plus 4 equals 0. Now, to undo it by square rooting, we need to get the x squared on one side. So I'm going to move the 4 over to the other side by subtracting it. I get negative x squared equals negative 4. Now, here's the thing. I still don't have an isolated x squared because I have negative, which means basically negative 1 times x squared. I don't like that. Let's go ahead and divide both sides by negative 1 to move that negative sign to our other side. At this point, I have x squared equals 4. Okay, step 1 is done. We've isolated the x squared. Now we just need to undo this square by doing the opposite and taking a square root of both sides. Okay, because the square root of x squared is just x. So x equals the square root of 4. Now, so square root of 4. Okay, I'm going to go back up to this step here real quick because you might just say, okay, x is 2, right? Right, we're finding values of x that make this equation true right here. Okay, if we plug back in 2, we have 2 squared equals 4. But you may notice we have actually another value that if we could plug back in for x that would make that true. So it could be positive 2 or x could be negative 2 because watch, negative 2 squared also equals 4. So we have plus 2 or minus 2. We can just write our answer as plus or minus 2. Okay, that is a way of writing both the positive and the negative answer. From here on out, when you take the square root of both sides, so make a note of this, when you take the square root of both sides of an equation, you're always going to have a positive and a negative answer. All right, plus or minus. Okay, let's take a look at one that's a little harder here. First, identify, does this fit the same mold? Well, I have negative 5x squared and a constant. That's good. It's the same form. So once I move this 9 to the other side, I'm going to isolate that x squared and take a square root of both sides. All right, if I do that, I get negative 5x squared equals negative 9. Still need to isolate that x squared. So same as last problem, I'm going to just divide by negative 5. If I do that, I get x squared equals 2. Now I have negative 9 divided by negative 5. I can just cancel out the negative signs and have 9/5. All right, at this point, we just have x squared equals a number. I need to isolate x, right? I'm just trying to get x equals, so I'm going to undo that square. And now I have x equals plus or minus, right? Throw that plus or minus in right at this step, and don't forget it the whole way out. The square root of 9 over 5. Now, so far so good, but we cannot leave it like this, okay? If you remember in our warm-up, we need to rationalize the denominator. Where is that? Okay, rationalize the denominator. No radicals allowed in the denominator, because in here we have the square root of 5 in the denominator. That's irrational. So first step I'm going to do is I'm going to separate and give the top and the bottom each their own radical. So x equals plus or minus the square root of 9 over the square root of 5. At any time, if you can simplify, go ahead and do so. So if we can pull out perfect squares, go ahead and do so. You may notice that 9, hey, I know that one. The square root of 9 is 3, so I get plus or minus 3 over the square root of 5, which is good, but I still have that radical in my denominator, which I cannot have. So I'm going to get rid of that. I'm going to move it to the top by multiplying by the square root of 5 over the square root of 5. If I do that, I should get plus or minus. Don't forget that, right? At every step, just so you don't forget it along the way. On top, I have 3 times the square root of 5. I can't combine those because one is inside the radical, one is outside the radical. So I just have to leave those next to each other as this 3 times the square root of 5. On the bottom here, I have the square root of 5 times the square root of 5, which you should know that this becomes the square root of 25, which just becomes 5, okay? We've created a perfect square, so we should just have 5 left on the bottom. All right, at this point, check if you can reduce maybe the 3 on top and the 5 on the bottom. I cannot. So at this point, that is my answer. Now, remember that plus or minus means I have a positive version of this answer and a negative version of this answer. All right, great job. Go ahead and try a couple yourselves and then continue on to solving by factoring.